So we went through the definition of the derivative, right? And there is all this long work that we go through. We are going to find ways to process and do derivatives where we don't have to go through all this, but you still have to know this, and I'm going to show you why at the end. So it's, even if you know what's coming with the shortcuts, yes, those are important too, and we will absolutely use the heck out of those, but we still have to know where it comes from and why. And so I'm going to go down here so this was all part of that last problem that she was doing, but I want to look at this stuff here. Okay, some notations. So you notice she did this f prime, and that is the derivative, right? That's what we did after we took the limit and did all that. There's different notations for the derivative and how you write them, and these are the most common. So f prime of x reads f prime of x. Right? Then y, this is y prime, it reads y prime. It's not y apostrophe, okay? Then dy dx, so it is dy over dx, but you read it as dy dx, or the derivative of y with respect to x. These all mean the same thing. We use different notations different times for different reasons, okay? And then d over dx of f of x reads the derivative of f of x with respect to x. So it's kind of the same thing, right? But we use f of x here instead of y, but you don't frame it up there. Okay, so this dy dx you'll see a lot, or dr dx, depending on what we're doing, but these are the different ways to see a derivative, okay? Then we have the alternate definition of a derivative. So it's the derivative of at a point, and we don't want to ignore that, all right? So we have an alternate definition of the derivative. So if we have the derivative of f at a point, it's just given by this, provided that the limit exists, okay? So we can't neglect it. Sometimes we use the alternate definition. But that's when you already have the point, okay? All right, so let's go through a couple of other examples here. So it says find f prime of x for, I think we're going to skip this one. Which one do I want? We're not going to do all of these. We'll start with number 2. So we're going to skip that one. Okay. So we're going to find f prime of x for this one. Then we're going to write the equation of the tangent line. Okay, so we want to write the equation of the tangent line. We don't want to forget to do that at this point. But we are first going to find f prime of x. This is the same thing as y equals, leave a little bit of space here, x squared plus x. Okay? Oh my goodness. So you know the whole, whatever you do to one side, you always do to the other. Got to make sure we understand our notations. If this is y, and I want to take the derivative, you're technically taking the derivative of both sides. So this is dy dx. I'm going to do, oh, that's not dx. I'm going to take the derivative of both sides. Okay? So when I do that, the derivative of y is either y prime, or we can call that f prime of x. Okay, that's what happens over here. Then over here, when we take the derivative, it is a limit. It is the limit as h approaches 0. Okay. And remember what we had? It's the limit as h approaches 0 of, and it's just the slope formula, basically, f of x plus h minus f of x over h, right? That's your definition of a limit. So when we go over here to do this, we've got, so f of x plus h, this is going to give me x plus h squared plus x plus h. Oh, that's a 5. Good for h. So that is substituting it into this part and this part, and that's all of this. Then I have to subtract x squared plus x all over h. Okay. Everybody with me? And remember, notation is everything on this stuff, and you can't drop that limit. If I don't write the limit here, it's not actually the derivative. Like, that's all part of it. And I don't get to drop the limit until I actually evaluate. So then my next step, I have to rewrite the limit as h approaches 0 of, right? So now I'm going to square this, right? So this is going to be x squared plus 2xh plus h squared right? Then I still have, so that's this part. Then I still have plus x plus h. And then this becomes minus x squared minus x all over h. Everybody with me on where everything came from? We good? You can't get lost in your little algebra. I mean, again, like she said, if you have to get this from here, if you need to go off to the side and do x plus h times x plus h and think through it that way, that whatever you got to do, just don't make this x squared plus h squared, or I will disown you. You at least need to know it's not that, even if you don't know what it is. Okay, so we all good? So we clean this up a little bit. We get the limit as h approaches 0 of, okay, so my x squared and my negative x squared, 0 out. This x and this x zeroes out. So I'm left with these three terms. I can rewrite them as it is, but could I go ahead and factor an h out of that? It's like whatever, let me rewrite it. Sometimes it's safer to rewrite it just so you don't get lost in your homework. 2xh plus h squared plus h all over h. There's nothing wrong with factoring out at that step, but you don't want to get lost in your work either. Then I'm still rewriting the limit as h approaches 0 of, now I can factor the h out in the numerator. That leaves me with 2x plus h, then what? Plus 1. Don't forget that 1. I still have to have 3 terms. All over h. So those h's cancel out to be 1. We're all good with that? So now I have the limit as h approaches 0 of 2x plus h plus 1. So now that I have it all simplified down, I can evaluate it. When I evaluate it, that's when I get to drop the limit. It's kind of like when I take the square root of 4. When I actually take the square root of 4, it becomes 2 and there's no square root sign, right? So when I actually take the limit by direct substitution, then I drop the limit and I get 2x plus 1. And what is that? What did we just find? The derivative. This is f prime of x, which is what we were asked to find. And what is f prime of x? Why do we even care about it? What does that give us? The equation. Does it give me the equation of the line? What does it give me the equation of? Where do we write that? I'm trying to find where it was on where we wrote on the notes. It's not the average rate of change. I'm trying to find it on the notes. I mean, I could tell you, but I want you to see the instantaneous. Blah blah blah. It's the slope of the tangent line. I don't see if it actually says that anywhere. That the derivative. I know it. It doesn't actually say that anywhere. Okay, so we need to write that somewhere. It probably does, and I just don't see where it says it. Okay, but the whole reason that we're finding this, and so on this one where we skipped this, here's where I want you to write. The derivative which is f prime of x, which is the same as y prime, okay, is the slope of the tangent line. And the slope of the tangent line gives you that instantaneous rate of change. because we have to keep track of why we're even doing this. Why do we care? Okay, so yes, it is the derivative. We found the derivative. The derivative gives you the slope of the tangent line. Because look, then it asks us to write the equation of the tangent line. So we have to use that to get to that point. Okay? So the derivative, which is f prime of x or y prime, probably going to use f prime for most of this right now. It is the slope of the tangent line. That is your instantaneous rate of change. Okay? All right, so let's go back to this question then. It said to find f prime of x. We did that. Check. This is equal to the slope. Right? Then it goes on to say, write the equation of the tangent line at this point. So to write the equation of a line, we need two things. We need a point, and we need slope. Right? Do you have a point? Yes, they gave it to us, right? It's 2, 6. Our slope is f prime of x, which is 2x plus 1. So how do I find the actual number for the slope? Substitute the 2 in. So that means that my slope is going to equal 5. Everybody okay with where all that came from? So now I have my point, I have my slope. I can write my equation, which would just be y minus 6 equals 5 times x minus 2. And like she said, it's fine to write it like this. There are going to be times where we kind of need it solved for y, but solving for y is super easy. We just add it to the other side. So if you're more comfortable writing it like this before you move that over so you don't mess up on signs, there's nothing wrong with that. And either one of them is acceptable. And just, you have to remember on multiple choice tests, it could look different. What if, back up here, it had said, write the equation of the tangent line, and it didn't say this, it just said at x equals 2. How do we come up with this? Because we need the point down here. How do we come up with the 6? Isn't this ordered pair just x, comma, f of x? Right? That's what your ordered pairs are. And this is my x. Look, this is f of x. If I substituted 2 in here, that's where I get my 6 from. Okay? So you would substitute the x value into the original to get the y value for your point. And then you substitute the x value into your slope equation to get the value for the slope. Okay, but you just got to keep track of which one you're substituting it into. Okay, does that help? We good? Okay. So let's do number 4. I'll push you out of your little comfort zones for a minute. Three, these are all kind of the same over and over again. You just have to, there's a whole lot more algebra in there, which you should be able to do just fine. Let's look at this one. So it says find dy dx. All right? So for y equals 4 over x. So your dy dx, that is the same thing as f prime of x, which is the same as y prime, right? When I take the derivative, I end up with the limit as h approaches 0 of, and so remember it's f of x plus h. I'll rewrite it over here again. It's the limit as h approaches 0 of f of x plus h minus f of x over h. So when I substitute this in, f of x plus h, I replace this with x plus h. So I get 4 over x plus h minus f of x, which is the same as y, which is 4 over x, all over h. Okay, so the way I usually work through these, or the way I would work through it in pre-cal or anything else, is I would leave it as a fraction and a fraction for a while so as not to confuse anything else. But let's try and not make it necessarily a fraction and a fraction so we don't have to look at all that mess. And I do that because I don't want to lead to other confusion, but I think at this level we could probably get this okay. Isn't this the same thing as the numerator being multiplied by 1 over h? Does that make sense? So if I just did 1 over h times 4 over x plus h minus 4 over x, do you agree that that's the same thing? Because basically I could just put this over 1 and multiply by 1 over h. That way, when I do that and I'm dealing with my common denominators here, I don't have it in like a big fraction and a fraction, and it's less of that mess happening. Okay? So does everybody understand how those are the exact same thing? Okay, just making sure, because again, don't want to add to confusion. I'm trying to make it easier. So then I'm going to add the limit as h approaches 0 of 1 over h. Now, the stuff in the parentheses here, I need to get a common denominator. The easiest way to get your common denominator is to multiply the two denominators together. So that's going to give me x times x plus h. Okay. So instead of actually finding this fraction and this fraction, I'm going ahead and combining it all. So that means that this fraction has to be multiplied by x over x, which means this becomes 4x. Then I have a minus, and this fraction would have to be multiplied by x plus h over x plus h. So we get minus 4 times x plus h, and it looks like that. Everybody with me so far? So then this is equal to the limit as h approaches 0 of, oops, I still have my 1 over h. 1 over h times, okay, so in the denominator I still have x times x plus h. In the numerator, I'm going to have 4x minus 4x minus 4h. Right, because I just distributed that negative 4 up there. Are we all okay with that? You gotta tell me if I lose you somewhere. All right, so then these zero out. So basically I'm left with negative 4h over this stuff. Since the only term I have left in the numerator is this term, and it's being multiplied by this fraction where I have an h down here, I can legally cancel those h's out. Do you understand why? Tell me if you don't. Do you understand why? Don't lie to me if you don't. You don't understand why? Okay. Thank you for being honest. So I'm going to ignore the blue stuff for a minute, and I'm going to rewrite this so there's less there. I think when there's less there, it makes a little bit more sense. I have h, as h approaches 0, of 1 over h times, and then I have negative 4h over x times x plus h. All right, so that's what I actually have once these two things zero out. Okay? So since I have that, when I multiply these, there's only one term in the numerator. Like, I can't cancel these h's out because there's more than one term down here, right? If this was an h, I could. So when I'm going to multiply these two right here will just cancel out nicely. Does that make more sense there? It makes more sense when you rewrite it. So again, I'm not saying take shortcuts. Rewriting it so you don't do weird stuff, not a bad idea. So now I have the limit as h approaches 0 of negative 4 over x times x plus h. Okay, and that's as much as I can simplify it down. Let's back up just a second here. Because here, I distributed the negative 4, but I did not distribute my x. First of all, I could distribute the x, but I didn't need to. I could tell I needed to distribute this to be able to simplify all this, right? If I don't feel like I need to do it, then I'm just going to leave it. Sometimes it makes things easier. Okay. All right, so now that I'm here, can I evaluate my limit? Yes, I can evaluate the limit. So I do direct substitution. I substitute 0 in here. What's x plus 0? X times x is x squared. So I have negative 4 over x squared. And this, since it didn't say f prime of x, it said find dy dx, this is dy dx, which is the same thing as f prime of x. And what does this tell me about my function? What does it give me? The equation of the slope of the tangent line. Because we have to find this is the slope of the tangent line. Then it says to write the equation. So in order to write the equation, I have to have a point, and I have to have the slope. They gave me the point. It is 3/4. My slope is negative 4 over x squared. Where do I get the x to substitute this in? From my point, right? It's right there. Just use that x. So that means that this is going to give me negative 4/9. Then once I have that, I can write my equation. Y minus 4/3 equals negative 4/9 times x minus 3. Okay. Any questions at this point? All right. This is the derivative that we are going to have rules for on how to do it without going through all of this. But no matter how we find it, it represents the slope of the tangent line at a specific point. Okay? We good? All right, so I want to show you a couple of things about why we need to know this, because I know, and maybe I should wait until we do the shortcuts, and you're like, why do we go through all that? This is an example of a question. It was from the 2017 BC test, but it is also AB materials, so it still could be something that, it's not a difficult question at all. But it gives you f of x. Okay, so then it's saying f prime of x. So you need to recognize that as the derivative and recognize this as the rule of the derivative. If you know that the derivative is supposed to be the limit as h approaches 0 of f of x plus h minus f of x over h, then which one of these represents the derivative? Or what could you eliminate right off the bat? Okay, why can you eliminate b and d right off the bat? Because it says x approaches 0. So boom, those are gone, right? Because it has to be as h approaches 0. Then between a and c, which one would be the definition of the limit? Well, this is f of x. This is just f of x plus h. That's this one is this, f of x plus h. I want f of x plus h, right? So x plus h has to get substituted in here and here, and that's what's happening here. So that makes your answer C. Okay, does that make sense? And you see the difference between this and this? Good. And then there's another one that I wanted to show you. Okay, so this is asking what it is, and we don't know how to do those yet, and that's fine. But you should be able to recognize this as the definition of the derivative, and you should be able to pull out f of x. If this is the this is something we're taking the derivative of, what are we taking the derivative of? What is f of x? Sine of 2x. So you have two choices here. You can either go through all this, or if you know how to find the derivative of sine 2x, which you will in the next few days, then you can just do it that way and you get your answer. Okay, but you have to recognize this. That's why we just went through everything that we did. Okay, we good on that? Perfect. Okay, good deal. Then